Welcome to another video. Here I'll be solving the 1998 AP Calc AB graphing calculator required part of the multiple choice, okay, part of the exam. And we are actually coming near to the end of this series of me solving all the released multiple choice questions, at least the years that I can find. Okay, so hopefully this has been helpful for you if you've been following along and practicing a lot of problems. I think that's the most important, just doing a lot of problems, seeing the types of problems that could be asked, reiterating just the concepts. For example, max min, that's derivative. Concavity, that's second derivative. Area under the curve, that's integral, definite integral, stuff like that. Okay, so hopefully this series has been helpful in that aspect as well, if you've been following along. Okay, so let's begin. This was actually very easy. This whole section, I finished it very quick in my first go. Okay, the graph of a function f is shown above. Which of the following statements about f is false? So let's go one by one. F is continuous at x is equal to a. We know that it's not, so we can already circle that. Why is it not continuous? Even though it's defined up here, right? Well, it's not continuous because limit as x, so let me write it down. Limit x approaches to a, f of x does not equal to f of a. That's the definition of continuity. F of a is this point. The limit is this point, though. So that's that. We can move on. I won't go through the other choices, okay? Let f be the function given by f is 3e to 2x, and let g be the function given by 6x cubed. At what values of x do the graph of f and g have parallel tangent lines? Okay, so tangent line, and parallel, that should signal like slope of the tangent line. And what is that? That's derivative, okay? So it's probably, these are easy to find the derivatives of, so let's just find them. F prime would be 6e to 2x, and g prime would be 18x squared. We just set them equal to each other on the calculator and we find the point of intersection. So let me do that. Okay, so I graphed it on my phone. You'll see, hopefully it's visible on screen, that there's this point of intersection. So we just find the point of intersection that occurs when x is minus 0.39, okay? So that's this guy over here. Okay, let's move on. Radius of a circle is decreasing at a constant rate of 1.1 centimeter per second. It sounds like related rates. I like to write down variables right away, what we are given as I follow along the word problem, okay? So radius of a circle decreasing, so we are talking about dr dt, that is decreasing, so it'll be negative 0.1, okay? In terms of the circumference, c, what is the rate of change of the area of the circle? So they're asking what dA dt is, and we have to relate it in terms of the circumference. Okay, so we need area of the circle formula, that's pi r squared. And we need circumference, which is 2 pi r. Okay, so we're asked what dA dt is. Let's differentiate here. dA dt is 2 pi r dr dt. We notice that 2 pi r is c, so we can rewrite it as c dr dt. What's dr dt? They give that to us, so it's negative 0.1 times c. So that was easy. Next, give me 1 second, sorry. Okay, graphs of the derivatives of the functions f, g, and h are shown above. Which of the functions f, g, h have a relative max on the open interval x is between a and b? Relative max, that occurs when the derivative goes from positive to negative, okay? These are the graphs of the derivatives, so we just have to see where it goes from positive to negative. We see it does go from positive to negative here, so this is good. Doesn't even cross 0 for this one, so not this one. Again, doesn't cross 0 here. So the only choice is F. So choice A. As simple as that. First derivative of a function is given by this guy. How many critical values does f have on the open interval 0 to 10? So we just graphed this on our calculator from 0 to 10. and see how many times it changes sign, okay? Or it touches 0, changes sign. We'll see, okay? Maybe it's trying to trick us. So let me graph that again real quick. Okay, so my phone app already put the units in terms of pi, but we know that 3 pi is around 9 point something, so it will be around 10 will be around here because we're interested from 0 to 10. So how many times does it cross 0? It's once here, so let me even zoom in a bit. Okay, so once here, 2, 3, and that's it, and that never crosses again, or it even touches 0, so it's just 3. Oh, this one was very easy. Let f be the function given by f is absolute value x, which the following statements about f are true. How does the absolute value function look? Looks like this. You should know this, okay? Is it continuous at x is equal to 0? It is, because limit from the left equals limit from the right. Okay, so the limit is 0 and f of 0 is 0. So this is good. Definition of continuity is met. Is it differentiable at x is equal to 0? This is the classic sharp turn example, so it's not differentiable. F has the absolute min at x is equal to 0. This is true because this is the smallest value, right? So it'll be 1 and 3 only, so D. If f is a continuous function and capital F prime is lowercase f for all real numbers x, then integral from 1 to 3 f of 2x dx is what? So we probably want to make a substitution because they give us this composite looking function. Let's let u be 2x, du would be 2 dx. So we rewrite our integral as, well, the inside is what? F of u and du divided by 2. So let's pull the half out in front. We have to change the limits of integration though because it's a definite integral. When x is 1, u is 2. When x is 3, u is 6. Okay, so if we simply find the integral of this, well, we know that capital F prime is f. So this is just telling us that capital F is the antiderivative of lowercase f. Okay, so this is half times f, capital F of 6 minus capital F of 2. Okay, so that's choice E. If a is not equal to 0, then limit as x approaches a, x squared minus a squared of x to the 4th minus a to the 4th is, well, we can factor the bottom. It'll be x squared plus a squared, x squared minus a squared. That's when we factor the bottom, right? And we see that this x squared minus a squared could cancel. So we're left with limit as x approaches to a, 1 over x squared plus a squared. So that would be, we just now plug in x as a. It'll be 1 over 2 a squared. That's B. Population y grows according to the equation. dy dt is ky. K is a constant. T is measured in years. If the population doubles every 10 years, then the value of k is, this is a classic exponential growth problem, okay? So if you remember the general formula, it's like y is ce to the kt. So I'm just going to rewrite it a little bit. Population, I'll call it P, is the initial population, e to the growth constant times t time, okay? So it says if the population doubles every 10 years, okay? So in 1 year, t is 1, then p would be, when t is 10, because it doubles every 10 years, my bad. When t is 10, then p would be 2 of the initial value, so 2p0. So let's write that. 2p0 would be equal to p0 e to the 10k. Once again, the population doubles every 10 years, so when t is 10, so that's 10 years, the initial population will double, so that's 2p0. Or 2 is e to 10k. We solve for k, as simple as that. So log 2 is 10k, or k is log 2 over 10. And if you plug it into your calculator, you should get, I wrote this somewhere, 0.069. So that's A. Okay? That's how we do this one. The function f is continuous on the closed interval 2 to 8 and has values that are given in the table above. Use the subintervals, these guys. Using these subintervals, what is the trapezoidal approximation of this guy? So you got to be careful here. These are not equal subintervals. So you can't use that general formula that you might have learned, depending on how your teacher taught it. So we just, the more safe way for this one is to just add up the different trapezoids, the areas of those different trapezoids, okay? Once again, you can see the intervals are not the same length. This is 3, this is 2, this is 1. So that general formula that you might have learned won't work. So you can't blindly apply that, okay? That only works when the subintervals are equal length, okay? So let's do it. So area of a trapezoid is average of the bases times the height. The height would be the length of each of these intervals. So it'll be, the first one will be 3 times average of the bases. So 10 plus 30 over 2. Next, this length is 2. And then we average these two values, 40 plus 30 over 2. Plus this length is 1. So, and then we average those two values. Okay, you can plug into your calculator. This is also quite easy. So this is 40 divided by 2. That's 20 times 3. That's 60. This is, these 2's would cancel. So we have 70. This is 60 divided by 2. That's 30. So this is 160. So you don't really need a calculator for that. Base of a solid is the region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 2y is equal to 8 as shown here. So they even sketched it for you. If cross-sections of the solid perpendicular to the x-axis are semicircles, what's the volume of the solid? Okay, so you won't be able to see it here, so let me just re-sketch it here. Cross-section perpendicular to the x-axis are semicircles, so I'm going to draw a representative semicircle. Okay, so the volume of the solid would be, we're going to sum up all these semicircles with small width or height, or whatever you want to call it, dx. Okay, so what's the area of a semicircle? That's half pi, if this guy is r squared. Pi squared is the full circle, so half is half of it, okay? So we set a small width dx and we integrate it. Okay, so what are limits of integration in terms of x? That's from 0 to 8. They give us the figure even, okay? So it's like this. This is the volume. All right, so what is r? R is this length. What's this length? That's this function. What is that function? Let's write it in terms of y as a function of x. So y would be 8 minus x over 2. So we can write our integral as integral from 0 to 8. We can even bring the pi over 2 outside. Okay, r squared, so this guy is r, 8 minus x over 2 squared dx. Okay, and this is a calculator problem. So you can just plug it in and did I do this right? Let me check real quick. Oh, sorry, this is not r. This is the diameter. This length, okay? So I did make a mistake here. I'm like, this doesn't look like what I got before. Okay, so let me erase and then I'll start the video again. So give me a few seconds. Or let me pause the video and do it. Let me pause it now. Okay, so I renamed this diameter as A. I didn't want to call it D because there's a D in this dx. Okay, so if we call the diameter A, all right, then the area of the semicircle is half pi a over 2 squared because we want to half the diameter first to get the radius. Pi r squared would be the area of this full circle, so we want to half that, so that's where this half comes from, okay? So I fixed that. And you can still just plug this, actually, well, what is A? A is this guy, okay? So it would be, so we can still pull the pi over 2 out. Integral from 0 to 8 of, it'll be 8 minus x over 2 divided by another 2, so that's 4 squared dx. Okay, let me put this in my calculator and check that my answer is correct. Okay, so I plugged it into Wolfram Alpha. It spit out 16 pi over 3, which is equal to, in decimal form, 16.755, something like that. So that should be choice C. Now let me confirm that's the answer. Yes. Okay, so sorry about that error in the beginning. I forgot to half the side, which is the diameter, not the radius. Okay. Which of the following is an equation of the line tangent to this guy at the point where f prime of x is equal to 1? Okay, so this is kind of asking that usual tangent line equation of tangent line in a different way. They give us what the value of the derivative is. We don't know what the point is, though. Okay, so we got to find the point. We have to use this derivative, though, to find that point, at least the x coordinate. So what's f prime? That's 4x cubed plus 4x. Okay, we set that equal to 1 to find out where this derivative occurs. Okay, and that is, well, if we set it equal to 0, now we use our calculator to help us find where the solutions are. So let me do that. So I get from Wolfram Alpha that x should be 0.23673, something like that. Okay, so if that's the x coordinate, we can get the y coordinate from here. So f of 0.23673 is equal to what? So again, we just use the calculator for that. So let me do that real quick. 0.23673, that guy, to the fourth plus 2, that guy, squared. So I get 0.115223, something like that. Okay, so we have a slope, we now have a point. We can find the equation of the tangent line. So it'll be y minus what we got here, the 0.115, I'll just round, I'll keep 4 places, is equal to the slope, which is 1, so x minus this guy, 0.237, let's say, 0.237, okay? So y is equal to x, so minus 0.237, I'm doing this in my calculator, minus 0.237 plus 0.1152, that's minus 0.1218, something like that. Okay, so that is D. Let me double check that that's correct. Yes. Okay, so just ask the typical equation of the tangent line in a different way. Instead of we had to find what the derivative is, they gave us the derivative, so we had to find what the point was. Okay, let capital F be an antiderivative of this guy. If f of 1 is 0, then f of 9 is what? Okay, so we can simply set up a definite integral. Okay, so let me squeeze it down here. So we can say the integral from 0 to 9, sorry, not 0 to 9, from 1 to 9 of ln x quantity cubed over x dx. Since capital F is the antiderivative, then this integral will be capital F of 9 minus capital F of 1. Capital F of 1 is 0, they told us. So F of 9 is just this integral, which we can put in your calculator. And if you do, you should get 5.8, something like that. Yes, so this one, C. Okay, that's how we do this one. And the last few problems. See, they allotted like 50 minutes for this, I think. And it's only been about 20 minutes, so we're more than good on time. If g is a differentiable function such that g of x is less than 0 for all real numbers x, and if f prime is this guy, which of the following is true? It's asking about the relative extrema. So we just do the first derivative test on this. We can factor f prime to be x plus 2, x minus 2, and then we still have that g of x. Okay, so we can do the first derivative test because we know we have critical points at -2 and 2. Because when we set this equal to 0, the critical points are -2, 2, and this guy is always negative, so it'll never be 0. Okay, and we're going to use this for the first derivative test. Okay, we plug in some huge negative numbers, so that's this interval. This would be negative, this would be negative, this is always negative. 3 negatives, the sign is negative. Plug in some number between -2 and 2, like 0. This is positive, this is negative, this is always negative. 2 negatives make a positive. Plug in a huge positive number, this will be positive, this would be positive, this is always negative, so the sign is negative, okay? So we see that, since this is the sign of f prime, since it went from negative to positive, there's a relative min here, and there's a relative max here, okay? Because it went from positive to negative. So that looks like B. If the base of a triangle is increasing at a rate of 3 inches per minute, okay, this is another related rate, so let's write it down. Base is increasing, so dB dt, let's call it, is 3. While its height h is decreasing, so dh dt at a rate of 3 inches per minute, so we put -3, which the following must be true about the area of the triangle. So what's area? It's half the base times the height. So is A always increasing or decreasing, or will it remain constant? So let's take the derivative, okay? dA dt would be half times, we need the product rule here. It'll be B dH dt plus H dB dt, okay? So the area would be, since there's more decreasing, let's go with the decreasing option first. The area would be decreasing if this guy is negative. So actually we can start plugging in some numbers because we know what dH dt is and dB dt is. dH dt is -3, so -3b. dB dt is positive, so plus 3h. So once again, the area would be decreasing because this is a change in area with respect to time. So it'll be decreasing if this term is negative. So let's write that as an inequality. -3b plus 3h is less than 0. Okay, decreasing, or let's say A is decreasing if -3b plus 3h is less than 0, or we say 3h is less than 3b, or h is less than b. Okay, and that's this one, choice D. Okay, so it's not too difficult. You just have to know that area is decreasing when this term, or this term, when we have to plug the numbers, is negative. So that's what I did. Okay, 2 more problems. Let f be a function that is differentiable on the open interval 1 to 10. If f of 2 is -5, f of 5 is 5, and f of 9 is -5, which the following must be true. So let's try to even imagine or sketch the points and where they are. Okay, f of 2 is -5, it'll be down here. F of 5 is 5, it'll be up here. F of 9 is -5, which is down here. Okay, and it's saying that it's differentiable from 1 to 10. So it includes this whole area, okay? This whole interval, I should say, not area, not to get confused with integral area, okay? It's differentiable, which automatically means it's also continuous. Okay, let me just write the whole word out. It's also continuous, okay? That's key for this problem, because when it says, does f have at least 2 zeros? It has to be, because it's continuous. So since it's continuous, for it to go from this point to this point, it has to cross the x-axis, so it'll have to have a 0. And similarly, to get from this point to this point, it has to cross the x-axis again, so it has to have a 0 here, at least 1 0. It could cross multiple times, we don't know, but it has to cross at least 1 time. So it has to cross at least once here, and at least once here, so at least 2 zeros. So this is good. Graph of f has at least 1 horizontal tangent. That sounds like Rawls' theorem. Remember what that says? It says if the condition that's differentiable, f of A is equal to f of B, then there's some value C between A and B such that f prime of C is 0. Okay, so since this guy and this guy have the same value, -5, then there must be some value C within 2 to 9 such that the derivative is 0, meaning there's a horizontal tangent. So this is good by Rawls' theorem. Okay? And finally, for some C is between 2 and 5, f of C is 3. This is testing, once again, intermediate value theorem, like this one did, okay? F of C is 3. Where is y is 3? It's somewhere here, right? This is, let's say this is 3, okay? Between 2 and 5, once again, since it's continuous, it eventually has to cross this line to get to this point. So this is good also. So all of them are true. Okay, last problem. If k is between 0 and pi over 2, non-including pi over 2, and the area under the curve, y as cosine x from x is k to x is pi over 2 is 0.1, then k equals what? Okay, so area under the curve, that should signal integral. Okay, so this is basically just saying the integral from k to pi over 2 of cosine x is 0.1. Okay, so we just have to solve for k. Okay, now how do we solve for k? Well, let's just apply the fundamental theorem in calculus and find the antiderivative of sine, cosine, which is sine. We evaluate from k to pi over 2. This is equal to 0.1. Okay, so I'm going to continue down here because I don't have space up there. So it'll be sine pi over 2 minus sine of k is equal to 0.1. Sine of pi over 2 is just 1. So 1 minus 0.1 would be 0.9 is equal to sine of k. This is you have to plug into your calculator. You should get k is what? I did this beforehand. It'll be like 1.12 in radians. So it'll be d. Okay, you got to be careful to put your calculator in radian mode. It should be in radian mode for even. I don't think there was some other problem I remember. We had to graph a trig function, so it should be in radians. Okay, but just double check before you solve. All right, and that's it for this part of the exam. Quite easy, as I said. Hopefully it was quite easy for you too. Please like this video if you found it helpful, and please subscribe to the channel to look out for it might be the last few videos for AB, at least for the released problems by the College Board. The 2012 exam is next, I believe, so look out for that, and please subscribe to get notified.